Hello there everyone. Our project for today is Regeneration in Marvel versus in Real Life by Cade, Morgan, Brandon, Angela, and George. So we're going to start off with the history of Marvel. Marvel started in 1939 as Timely Publications, and by the 1950s had changed its name to Atlas Comics. The trademark Marvel name started being used in 1961 when the company launched the Fantastic Four. Marvel has a ton of well-known superheroes including Spider-Man, Wolverine, Hulk, Thor, Doctor Strange, Iron Man, Captain America, Daredevil, the Avengers, the X-Men, and the Fantastic Four. Marvel also has its fair share of villains including Venom, Doctor Doom, Red Skull, Green Goblin, Thanos, Ultron, Dr. Octopus, or Doc Ock, Magneto, and Loki. So we're going to start off with Deadpool first. A superhero, and may be considered to some extent a supervillain, who first appeared in the Marvel Comics New Mutants number 98 in 1990, and more recently in the live-action movie Deadpool. His powers include a superhuman healing factor derived from that of the mutant Wolverine that allows him to regenerate damaged or destroyed areas of his cellular structure at a rate far greater than that of an ordinary human. As such, he can regrow severed limbs or vital organs. The speed at which this healing factor works varies in direct proportion to the severity of the damage Deadpool suffers. This healing factor also affords Deadpool a virtual immunity to poisons and most drugs, as well as an enhanced resistance to diseases and an extended lifespan. And more stuff about Deadpool. So unlike Wolverine's natural healing factor, Deadpool's is mentally driven to a partial extent. Due to the presence of this superhuman healing ability, many of Deadpool's natural physical attributes have been enhanced. For example, Deadpool's musculature generates considerably less fatigue toxins than the muscles of an ordinary human being, granting him superhuman levels of stamina in all physical activities. His natural strength, agility, and reflexes have been enhanced to levels that are beyond the natural limits of the human body. Deadpool's agility and reaction time are superior to those of even the finest human athletes. And we have two clips of Deadpool. The first is going to be from the Deadpool movie where he cuts off his hand.
Let us go talk to the professor.
McAvoy or Stewart? These timelines are so confusing.
Oh, dead or alive, you're coming with me.
You'll recover, Wayne. You always do.
You ever see 127 Hours? Spoiler alert.
Oh my god, nasty.
Oh, there's the money shot, baby. Are you there, God? It's me, Margaret. Rock, meat, bottom.
The next clip is where he's going to show off his little baby hand.
About the size of a KFC Sport.
So, more information about the clips. When Wade regrows a hand in the movie, it looks just like the arm of an unborn baby. This accurately reflects the regeneration process, which resembles the development of an embryo. The majority of adult body cells have different specialized roles, such as skin being a protective barrier. Regeneration turns those mature tissues into stem cells that can divide and differentiate, giving rise to everything from skin and bone to muscles, nerves, and blood vessels. When the body is breached, its outer layer forms a wound epidermis that releases growth factors to stimulate nearby cells. Fibroblasts, the cells that make collagen fibers, are crucial. Salamanders are able to reprogram fibroblasts to become a blastema, a ball of stem cells. Deadpool's body would probably do the same. On to Wolverine's regeneration now. He can heal himself, which makes him resistant to drugs, diseases, and toxins. Wolverine has a protein in his tissue that is similar to Amblox, but in the movie, the other protein is a made-up protein called Whole-Wit. Comparing the Whole-Wit to the Amblox, Whole-Wit is more concentrated in comparable cell lysates and increased replication and regeneration. With how strong his regenerative ability is, he only needs to have one drop of blood left and he can completely regenerate his entire body. Wolverine's weaknesses. So, the Muramasa Blade, which is a katana that has a supernatural power which nullifies his healing power. And also, Wolverine can actually drown if he is held underwater for a long enough time. And of course, there is regeneration in animals. The most famous animals that can regenerate are sea stars and geckos. Sea stars can grow entire new sea stars out of a chopped off arm, and geckos can grow new tails. There's also a species of jellyfish called the Turritopsis dorni, or it is known as the immortal jellyfish. At any given time, it can revert to the polyp stage, become a new polyp colony, and completely transform into a new jellyfish. Supernatural regeneration. Supernatural regeneration is the ability to heal at an alarmingly fast rate. In most cases of supernatural regeneration, it is in superhero movies or TV shows and other fictional media. The character may regenerate lost limbs or damaged tissue and organs as long as the core of the character is unscathed. Because the cells of a superhero or villain are constantly regenerating, the amount of damage sustained by the attack is not enough to incapacitate or kill them. However, when the cells of an actual real-life organism recover or heal, the process is much longer. And regeneration in humans. While humans can't regenerate a limb, we can regenerate some organs such as the liver. Our skin is constantly being renewed and repaired. Also, things like our nails regenerate themselves. If you have your nail fall off, it can fully grow itself back. We can regenerate, but not perfectly like Wolverine or Deadpool. For example, our liver will grow back to its original size if damaged, but not to its original shape. Our skin doesn't fully repair either, and instead leaves a scar. And here's some pictures of regeneration in humans. As you can see, you have different things that can regenerate very quickly, that can regenerate moderately, and some that regenerate very slowly. And as you can see right here, here's a picture of liver regeneration occurring. As you can see, it's kind of just doing its thing. Well, we hope you enjoyed our presentation, and thank you for watching.